Hi there, and welcome to this Integr8tor 2020-12 release video. My name is Dirk Leroy. I'm with UCAMCO in Ghent, Belgium. And what I would like to do in this video is to take you on a quick tour of our latest Integr8tor software revision and spend some time on a number of features and extensions that we have built in. And in order to help us through this, I will use this release overview, which has the highlights of the version and which will allow me to do some explanation and show you a few examples of what is mentioned in here. Okay, so there we go. If we look at the highlights, the main ones are here on the first slide. We will be talking about backdrilled PCBs. There is an item on the so-called Altium PCB input connector. We have something about DPMX, extensions on conditional formatting, and a number of other items which you will see towards the end of the video. So if you would start, or if we would start with the first one, the first one is support for, or QED support rather, for backdrilled PCBs. Now to get this straight, or to make sure that we are all talking about the same thing, I should have here, if all goes well, a Word document, yes, with some images that I've just took from the internet, so nothing special. I think this comes from the Altium online documentation or so, whatever. But it gives us a nice example or an illustration of what we are talking about. What you see here is basically the barrel, a through-hole barrel of a PCB, which is in very, very many cases exactly the way you see it here. It goes from top to bottom. Now, what you see here in this one is basically this barrel here basically only serves the purpose of taking a signal from the top layer, in this case to layer number 3, and have it continue there. And really all the rest here is has no function, no real function. Now, in many standard products we couldn't care less about this non-functional parts, but once you start talking about high frequency boards and you get into the area of 5 gigahertz, 8 gigahertz, 10 and more, what happens is that this remaining part here, this remaining part of the barrel is causing noise. It sort of disturbs the signal that basically has to go from layer 1 to layer 3 by reflection, jitter, whatever. So what we have seen is with the advent, for instance, of the 5G telecoms, that many of these boards need this so-called backdrill procedure, or sometimes also referred to as depth-controlled drilling. And what that will mean is there will be an extra drill run, which is going to mechanically drill the barrel, which at that point is still complete, to drill the barrel back to a certain level, as you can see here in the second picture, to make sure that at the end, this last part of the barrel, which they call stubs, or which is called stubs, by the way, so that these stubs, they get removed. Yeah, so that's the back drilling, and contrary maybe as to what you may think, back in this case does not refer to the fact that it can only come from the back side. The same could happen exactly in a case where you go from top down, and if your signal connection is going from, I don't know, layer 9 to layer 12, for instance, and then you would want to remove the top side of the stub. But as a technique, this principle is called back drilling. Now, why would that be so important? Well, it's important in a number of ways. I mean, not the backdrilling itself, but the support that we offer in our latest software version. The support for this backdrilling is something that I would like to show you, maybe by means of an example that I should have here in my cockpit. If all goes well, we have here a backdrill example. So this is one of these boards. It's a fairly big board where you have all these through holes, quite a few of them. I think in this job there is like 4,500. And then a number of these holes, they need to be backdrilled. And what this boils down to is basically the following. If you get a data set for such a product, the data set of backdrilled products, and you would open the zip, which I have done here, is you will find your copper layers, a whole bunch of them. And at some point you will see all these drill files, drill files appearing. And basically they are, as you can see from the names here, some of these holes that we were looking at in the board here, some of these barrels need to be drilled from, or drilled back, I should say, from layer 1 to layer 4. And then there is some other holes that need to be drilled from layer 1 to layer 6. So the end layer is a little bit, or the end layer is lower one. Some holes from layer 1 to layer 8, from layer 1 to layer 10, and so on and so forth. And you see here that this is an example where the same thing happens, but from the other side of the board. Then from layer 24, there are 24 copper layers in this board. From layer 24 back to layer 21, some holes need, or some barrels need to be drilled back from layer 24 to 19. So it's always from the, typically from the outside of the board down to a certain depth in the into the product. Now this is a relatively standard product, and you can already see it has, I believe, 16 backdrill layers. So setting this up, because you will have to tell the software that these backdrills are there. So setting this up is not an evident thing to do, and it will take some time, and you really need to be focused to get this done properly. So in our new backdrill module and integrator, what we do is basically three things. We will first of all see that in the incoming data, or from the incoming data, we will see that there is backdrilling involved, so that this is a backdrill product. What we will then do is we will identify all of these backdrills and do this whole definition of their span, starting layer, stop layer, from where to where they should go, is something that we will do automatically from top side, from bottom side. And once all of that is in place, our design analysis routines will feature a number of extra outputs, so a number of extra columns and items on the QED PDF report that will give you specific information about the backdrill and the situation of the copper around the backdrill. I have taken the job that we were looking at in the cockpit. I've taken it here into this UCAM XWE, just to give you a feel for what this is. So you have a through hole going from layer 1 to layer 24 in this case, and then you see you have all these backdrill layers that we saw just a while ago in the zip or in the archive, going from top to blah 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 blah. Yeah. So as you can see, quite a few of them. That's all I think for here in my UCAM. Let's go back to the cockpit. What you will see is, for the purpose of this backdrilling, we have a new system class. System class, or functions as they are called here. Functions are the things by which we tell the software what a certain layer is supposed to do. We have outer layer, solder mask, legends, you know all these. And with this software release, there is a new function or a subclass which is called backdrill. And that too is going to be an automatic routine from our software. When these backdrill layers have been read in and identified, we will assign them this specific class, so that later on during design analysis, the software knows what to do, what is involved, and all this fancy stuff gets done automatically. Yeah. I'm not going to do this live. I'm not going to send this job off with 24 layers and this drill and backdrill. This would make the video probably a little bit too long. But what I can do, or what we will do, is definitely have a look at the QED. So I've run this yesterday evening, or whenever time I last did it. And so what you will see, or what you will have, is in your QED report, there's going to be a number of additional items. So we're looking at the QED PDF now. And for instance, here in the summary, you will see an extra column, which is then called copper to backdrill clearance, for instance. And it will specify, just like for all the rest, on your outer layer, your distance from the nearest copper to the backdrill is so much. On your inner layers, your minimum is like this. And like that, there is in the next section, for instance, you will see where the sequences are listed, the PTH and the NPTH, which we know from already a long time, have been there all the time. There is now this new category, or this new class, this new system function I told you about, that will be stated as backdrill, and where we will do the same reporting or the same analysis, how many there are, how many tools are there, what's the minimum and maximum diameter. Usually the diameters in these backdrills, they should be slightly different than the diameters of the PTH, in order to get rid of the barrel. What they will do is they will make the drill diameter slightly bigger. And then you will get things like reports of the rings, if there are any, for your outer, the ring on the outer or the ring on the inners. There is a whole methodology involved in this for producing this thing, and based on the figures that you see here, you should be in relatively good shape to say that the incoming data set is okay for the back drilling, or whether there is still stuff to be handled later on in CAM. If we go back to this document with the images, what I have done here is I've basically taken out of such a QED all of these sections in the report where you would find references to the backdrill. So we had in the live QED report we saw a minute ago, already looked at the summary for the copper minima, the sequence summary, and then if we go further down, you will recognize this as the file list, which is part of the QED report, where there is also the information about the backdrill layers, from where to where they go. In the copper layer minima, the copper to drill minima, sorry, you will also find reference to backdrilling. There is backdrills being listed and their characteristics in the drill tools sequence, which will tell you more of what you want to know with the or about these backdrills. There is from the drill perspective, or from the drill point of view, sorry, not the drill perspective, that's something else. From the drill point of view, the drill versus copper clearances that will be listed here, and so on and so forth. So there is quite a few sections on the QED report that will now talk about backdrill, provided of course that the product that you're analyzing is a backdrill product. If it's a regular job, nothing to do with backdrill, these columns will not be there. So they will only appear, these columns and these rows, they will only appear in case of really we have identified an incoming data set as being a backdrilled product. Finally, you see here also in the part that you will recognize as from the detailed images, typically at the end of your QED report, where you have these zoomed up images. Also there will be references to backdrill, yeah, to get you to the minimum. Okay, I think we can get out of here, and then maybe here. Is there something else I wanted to talk to say about this? It's a licensed feature, so you, if you want to evaluate this, just get in touch with the license department. They plug in the license, and if you deal with this kind of product, just as I say, have a trial license for starters and see what it does for you, and how it can make life easier for the people who have to deal with this type of product. Okay. So far for the backdrill. If we go back to where we're here, the report. So the fully automatic didactic input, we said, the special or dedicated classes, and then the comprehensive backdrill specific QED analysis, all these columns and rows that we were looking at. Number two, also a new option and coming with a license by itself, is the Altium PCB input connector. Altium has actually a CAD package with a fairly impressive installed base. There's quite a number of Altium users, and many of you people out there regularly receive PCB doc files, and PCB doc files are basically the native format of the Altium designer package. Yeah? So rather than sending you the Gerber files, what a number of your clients may do is that they will send you basically the native database, the PCB doc file from their Altium designer, and that will then it's your in your hands to get going with this. I have here, while I'm doing the explanation, this is, I believe, the PCB doc. I'm going to submit it to my integrator because there's some things that I wanted to show or want to show you. I'm doing this from send to. I'm basically dumping this into a hot folder. But really, once I have done that, we should, okay, there it is. It should appear over here. And what we do for this is a little bit special in the sense that we are not going to convert this format ourselves. What we do is we are linking, as you can see here, we are linking an Altium Designer software package to Integr8tor. So what we will do is upon input, what will happen is we will see that it's a PCB doc. And if the link is there, we will pass this on to the to an Altium Designer cut package, which is installed on the or should be installed on the Integr8tor server. Yeah. Now, for the purpose of this demonstration, I'm doing this on a laptop. And like many of you, probably I am confined to home office because of COVID. So my laptop is basically at the same time my Integr8tor server as my Cockpit. But in a normal setup, the Altium Designer package is basically going to reside on the Integr8tor server. And if you would have, say, 5 cockpits from which you can send data to Integr8tor, then on these Cockpit, on these clients, nothing would have to be done in some special way in that respect. Yeah, so you will have only the software installation on your Integr8tor. Now, as it so happens, we hear that in quite a number of cases, PCB fabricators already have a license of Altium, and that they are doing basically what I'm doing now, that they are doing this basically offline. If they see that they get in a PCB doc, an Altium native, somebody will go to a separate application, read the PCB doc in there and convert it to Gerber or Gerber-X2, to then take these Gerbers and bring it back to Integr8tor and zip it and launch it then through Integr8tor. Well, this is basically exactly what has been automated with this package. As soon as we detect it is an Altium native database, it actually goes to Integr8tor server. From there we launch the Altium application, the designer application, and the PCB doc is converted into Gerber-X2 files. Yeah? So Altium Designer is producing high quality Gerber-X2 files with all sorts of attribute information. So what will happen is these Gerber-X2 files, as you see here, they get returned to Integr8tor, and Integr8tor will read them. And because it's Gerber-X2 and rich in information and attribute information, we're guaranteed that the stack-up will be correct and automatically set each time for all of these cases. So it's actually a fully automated link where we sort of temporarily pass by the Altium Designer software to do a little bit of the work for us, and then take the result from this conversion, take it back to Integr8tor, and let it go through a regular QED analysis. To have this functionality, there is a license in Integr8tor. We do not provide, UCAMCO does not provide the Altium designer license, of course. That is something that you will organize yourself. But if it's available, then if you just make sure it gets installed on the Integr8tor server by plugging in the Altium PCB input connector from our side, you will have this live link, as it were, between the two products. Okay. In the meantime, it has finished processing, and as you see, it has the stack up, it has the legend, it has the solder mask, the paste. So that's fairly straightforward and relatively easy. So basically, it takes away the burden of having to go somewhere yourself as an operator and find the software application or find somebody available to do this conversion from a PCB dock native Altium to something that we can use in Integr8tor. So far for the Altium PCB connector. The next one in the list also ranks in the category of data input, and that's the DPMX. If my memory does not let me down, that stands for Digital Product Model Exchange, I believe. And it's a new name for what has formerly been known as IPC 2581. It is an emerging format. There is a growing demand for that. A number of your suppliers or people who will send you their CAD designs. There is a growing tendency in there to see IPC 2581 or DPMX, and as such we have provided for a input processor which is available both in our newest UCAMX release as well as we say here in our Integr8tor. Not that it is very spectacular, but I think I also have something here. Yeah, it's basically this DPMX is basically an XML file or an XML format. It's documented on the web, so you can find whatever information that you will care to find out. You will find it there. I'm going to do the same thing. I'm going to just send this zip to the hot folder, and if all goes well, we should see it appear here in the in the auto input, the my job list. Okay. While it is chunking away, I have the converted versions of some of these jobs here. I think that's the one that I have just launched. We will just let it go through and come back to it later on if we see that it's finished. But in the end, as we said, it's a single file database. So it has both the information for the coppers, the drill, all the extra layers, the stack up information is there. So again, it's one of these formats where you are pretty sure that once you throw it in, you don't have to worry about any questions about stack up or things that have not been sorted out, because it's an all-in format, so that should be relatively okay. While it's doing that, let's go back to our document again. Like the other two, the first two, this is also a new option, so there's a license for that. If you care to have one on evaluation, just let us know, and then you can take it from there. Where are we? Number 4, huh? Yes, number 4 in the list has to do with conditional formatting. Conditional formatting, maybe just to refresh our memories, conditional formatting is the ability in the QED report to have some of these cells colored in red. Yeah, and colored in red means that this is a value which is suspicious, or a value which is below a certain minimum, or it's something to attract the attention. Yeah, amongst these 1,000 digits that you see on the report, those cells will then catch your eye, and you will know that there is something to look at. Now, conditional formatting in itself is not new. We've had that for a very, very long time. But up until now, we had a situation where if you set up conditional formatting, you would just say, this cell, if ever a value gets in there and the value is less than, I'm making this up here. But if the value is less than 150 micron, then the cell must become red, because I know that less than 150 micron is weird or dodgy or needs to be looked at. Yeah, that was the system as it existed up until now. What we have done in this release is that we have extended this feature to be able to take into account copper weights. It's a very common thing that if you say I have a minimum trace width of 150 micron, the 150 micron doesn't say everything really. I mean, the 150 micron is probably not a problem if you have to etch it into, I don't know, 70 micron copper foil or in 35 micron copper. But the same 150 micron may be more of a problem if you have to go to 105 micron copper, for instance. Yeah, so depending on the copper thickness, depending on your copper weight, these clearance values in your design and these line widths in your design, they have to be put in a different perspective, and that's exactly what we have, what we are doing with this option. If all goes well, I have here a job which I have already put into the system. And if we look at the stack up, it is currently set up, this job. It is set up for a copper weight of 35 microns on a dielectricum, whatever. Yeah. So it's a 2-layer job, relatively straightforward. And if we would look at the report, I've made here a special QED with less information than normal, just for the purpose of the demonstration. If I would take this QED report, what you will see here is two things, two extra columns here. With this version, we have the ability to define the copper thickness, and you will see this displayed in the files list. Yeah. We have a base copper and a finished copper thickness. Just bear that in mind. We'll come back to that in a minute. And a bit further down here, we have the picture. But we also have, let me grab this by the scroll bar. For the sake of this demonstration, we will keep an eye on this particular cell here. It's the cell which is called critical trace width. Yeah. So from the analysis of the job, you see that in this product, the minimum critical trace width on the top layer, let's say, is 254 micron. And as you see, it's just the value there in its cell, nothing special. But look what happens when we say, okay, this is all fine. But if this product had to be produced in thicker copper, and I'm now going to SpeedStack, which is our stack up and material product that we offer in combination with Polar. If I go there and I would say, well, this core with this copper cat core is basically not what we want. I'm going to change it to something else, and that something else is going to be from the same Hitachi. But I'm now going to put in 1.6 with 70 micron core on top and bottom to see what that does. So I have swapped one core for the other. We now get the 70 micron copper top and bottom. And when I press apply finishes here for all materials, what we will see here on the right is basically, this is the base copper, 70 micron. The 95 is the finished copper thickness, which you will get after plating your barrel. Let's assume we have an extra 25 micron that is going to be added to the 70 micron. So with this new material in place, what we do is we go out of here. I make this new material and stack up information, I make it available to Integr8tor. As you can see, that's another example of where we integrate with another product, just like what you saw with Altium Designer a minute ago. So to go to and fro from or between UStack and Integr8tor is basically as if it was one of our own applications. And what we will do now is it shouldn't process too long. I think we will be done in a couple of seconds. And when it's done, if we go back to the same QED that was a little bit too quick probably. If we go back to the same QED report, there we go. We would find, if all goes well, in our copper information, we are now talking about the 70 micron base copper with the 95 finished copper thickness in there. We have the stack-up picture, which is updated. And as you can see, although the value, the minimum trace width, is still the same 0.254 millimeters, the cell itself has now become red because the same trace width, but in thicker copper, would be, let's say, more difficult or whatever. Yeah, this is, I mean, this is just for example's sake. How is this done? Let's have a brief look. As you may know, or some of you may know, conditional formatting is basically ruled by a file called conditionalformatting.xml. It's in one of the software directories. And basically what we have done is the following. If I go to this setup, and I've been there before, I should be around line 329. Yes, that's the one. Yeah. Basically, this is the name of the cell that we were looking at a minute ago. Minimum track trace. And as you can see here, a little bit lower, let's take this one. This was the old system where you would say a cell must become red if, in this case, the value in this cell is less than 75 micron. Yeah, that's what we had before. And with the new software release, what we do is we say, okay, that same cell, if the copper weight is between 0 and 35 micron, and the value would be less than 200 micron, then this cell must become red. But this cell can also become red if my copper weight is between 35 and 70 micron, and the value that goes in the cell is less than 250. Or the third reason, and that's the thing, that's the rule I think that has been applied in this case. If the value is less than 0.3, it was 254, and the copper weight is between 70 and 105 micron, then that too is a reason for turning this cell red. By the way, for the copper thicknesses, specifying the copper thickness, you have the choice between taking into account either the finished copper weight, what was it, the 95 in my example, or the 90, whatever, or the base. If you would rather do this, depending on whether you do pattern plating or panel plating, you can do this also with the base thickness, and then of course the same system will work, but it will take into account the base thickness rather than the finished thickness. Okay, this is an addition to existing software. Conditional formatting is basically there for you to be had. If you're not comfortable with setting this up yourself, feel free to give the people at the hotline a call. They will be happy to oblige and make any modifications that you would like to see go into this file in order to make it behave the way it should. In the meantime, I think we also have come to, where was it? Was that the WBE? Yes, that was our DPMX input, which in the meantime has completed as well. I mean, not just the input, of course, it has also gone through the regular QED analysis. So as far as that is concerned, you would find the same information that you will see on a regular QED report. No? Okay. Back to our overview. Let's see, where were we? We were, yes, we had been looking at this conditional formatting and the copper weights. And then if we would go one further, this is actually linked to it. It's the copper weights that you saw me modifying to go from one copper thickness to another thickness, which, as you saw, was done in the UStack product. Sorry, UStack. The next one on this slide here is called time registration. And what is time registration? Well, maybe a keen observer has already seen that in the cockpit that I'm using, there is this, or there is an extra column here called interactive time. And what interactive time does is it's very straightforward. You know, you have all these submit times and the run times and the cumulative times when a job is processed in batch, yeah, in the automation engine automatically. Interactive time is something that basically registers the time that you spend or that you have for the job that goes to UCAM. So if you would take a job to UCAM, like you've seen a number of examples here, if I have a job and I take it to UCAM, then that sets off the stopwatch, and if 2 minutes later I return the job from UCAM to Integr8tor again, then the time that was in there, sorry, that's one which is at 0, excuse me. This is one that was edited interactively, for instance, for 31 seconds. So that would then become visible and available in this interactive column. This is one of two possibilities. The other variant on the same theme is that you want to add your interactive time to the full duration. So that is also a possibility. That is just a setup or a key to be set somewhere where you can make this 31 seconds then to be added to the 5 minutes and 25 that you see here, to have everything in full duration. Its practical use is basically if you see that for a particular customer or for a particular situation there is this repetitive need for interactive manipulations because, I don't know, the stack up is not okay or this or that needs to be changed, then this might be a good hint to pick up a conversation with your customer saying that, look, your outline always is a bit dodgy. If in future you could make it like this or that or something else, then it would help us immensely, and this whole thing, these jobs would run through more automatically, which is of benefit to everybody in the process, so to say. Yeah. So this is what it does. How do you set it up? Yeah, it may not be there from the beginning. Let's just have a look here. You know, is Cockpit? No. Where do I want to go? Where do I want to go? It's in the views. Yes, of course. Here in the views section of your preferences, you can define which columns that you see. Yeah, and there is a new column called interactive time, which I think after installation by default will be in the non-visible part, but then you just pick it up and drag it over here and you position it where you want it to go. First column, second column, third column, and so on and so forth. You just save it, and from that moment onwards, the cockpit will update itself, and the column will be here. As for the addition of the two values, interactive time to full duration, it's something in user preferences, but by all means, feel free to give the people at the hotline, drop them a line, and they will be happy to tell you how it's done or to come on your system and do it for you, no problem. That was our interactive time. Let's see where we are. Those, as long as we are with the cockpit, another very nice one and something that a number of people have been asking about is a system to automatically log off a user who is no longer active, in the sense that there is no movement of the mouse or the product on his laptop or on his PC anymore. It's a problem that has become a bit more acute since we are all working from home now, and sometimes these VPN lines drops, and I mean we all know how this goes. And then on the server, all of a sudden a license is used or still in use, which is basically serving no purpose anymore. You have the thing with the VPN going dead at some point during the day, maybe. There is also the case where in the evening a person finishes his work and he forgets to log off his cockpit. And then the people from the night shift, for instance, they are short of a license because his application is still open. So in order to have this remedied, what we have in the, I'll briefly show you, I could have done it a minute ago while I was there. If we go back to the preferences and you would go to logins, I believe, yes, it has an extra entry here where you can specify the automatic log off after, in this case, 60 minutes. So if there is 1 hour of inactivity, on the cockpit, then this session would be terminated and the user would be logged off. To the definition of activity is that as long as your cockpit is like this, the mouse is moving, then there is this Windows system that can register this, and that's all fine. If I minimize this, for instance, my cockpit, and I would now do this document, or I open my email and do some other work. As soon as the mouse cursor is no longer hovering over the cockpit application, that's when the clock starts ticking. So that's when the 60 minutes start. As soon as I go back, so the system may now have registered 35 seconds of inactivity on my behalf. If I go back here and I go to the cockpit, the counter is reset at 0, so the 35 seconds from a minute ago are forgotten, and I start with a fresh count at 0. So that's how it works. It is a continuous duration of 60 minutes of inactivity that will lead to the automatic log off. That too is something that will be you will find it there after the installation of the new software. It doesn't require any license additions or any license update. That was basically also the same for the time registration here, which I forgot to explicitly mention. So that too is something that will be there once you see it. Yeah. Another item on the QED is an extra information on the assembly panel, and it's about the route length analysis. You know that in a number of places on the QED we talk about route and route lengths, but what we didn't do yet is when you create or when you specify an assembly panel yourself via the sizes editor, that one will go and sit, of course, in a production panel later on, and that too needs to be depanelized, as they call it. Yeah. So really, the routing out of the assembly panel from the production panel is a routing distance which represents a certain time and a certain effort, and it is that length that we are reporting here in the last column from the customer panel section that you have on your QED report. It's the dpanel route length, so that would be the routing which is required to get this one out of the production panel, as we said. That too is something that you will find in your reports. It doesn't require anything extra or anything new. Then we come still for the QED, we come to the solder mask bit. There is the addition of extra surface finishes and solder mask colors. It's something that, because I was not doing manual job submit, it's something that we haven't seen, but if we would go to submit job, and you would turn to what was it, solder mask colors, you will now find a number of new ones. You see there is the matte green and there is the pink. I think also the purple is new. I think for this release there is a clear one. I think we added 4 or 5 for which there was a relatively popular demand. And the same, as long as I am at it, the same goes for surface finishes. For surface finishes, as you can see, Also, this list has become longer. You may also notice that hot air solder leveling and hot air solder leveling lead free are now two individual items. They used to be combined in one, but from what we are told, the cost factor for the two are fairly different, and there is an advantage in having them separate. So we split them up, and at the same time, also here we added a number of them. I think tin plate is one of the new ones, carbon ink, and I'm forgetting one or two, but you'll see for yourself if you open the list um, what new surface finishes are there to be used. Okay, that too is part of the standard application and the update that you're getting. So that too is under control. The other thing that had to do with where are we? We are here. That has to do with the solder mask is some QED solder mask analysis extensions on the report, and I can probably, let's go back to Cockpit and we have a look at one of them. Let's, it doesn't really matter. Should I? Yeah, whatever. If I go to the QED, and we would go down, 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 down. I am looking for where is my solder mask? Solder mask, solder mask. There we are. We have these new items here, one side covered vias, both side covered vias, and no side covered vias. And what it also allows me to show is you see these little eyes here. That's another feature, a new feature that we are just starting to explore with this new software release. It's basically tooltips within the QED PDF report. So if you hover over these items that have the little blue eye symbol, then you will get an explanation. As I said, this is just a first version. You will see this tooltip feature become more and more important in the versions that follow. So the one side covered vias would be a column where it says the through-hole vias that are either partially covered by solder mask on the top layer and partially free on the bottom. So it's basically an extra piece of analysis to determine or to identify cases where openings on the top side of the board, the solder mask openings, sorry, openings in the solder mask on the top side of the board are different in some respect than the one on the opposite side. Yeah, so that is what you will can derive from these three new columns in the QED report. This is where we were. So we had the extra finishes and solder mask colors that we had a look at. There is these three additions for solder mask analysis. The annotated QED PDF as well. The one that we just talked about, where you have the tooltips popping up. And then finally, as you may have seen, we have done a little rework also on the PDF summary table revision. The PDF summary table revision is basically this first part, typically in your QED report. I mean, that's where we put it default, which has basically the essentials. So that's the place where you look to find all the basics of the board. I think we have moved some of these parameters and put some more popular ones in there, and then rearranged the order. But have a look for yourself, and you will see that this is quite useful as well. The version is available on our FTP, so you're very happy and welcome to download it. I hope you enjoyed this video. As we said, if there is any queries or questions that you still have, feel free to contact our support people. They'll be happy to lend a hand. I think that's all from me for now. Thank you for watching, and we talk again soon. Bye-bye.